So we're going to do odds in section 12.3. It's odds for and odds against. And this, for some reason, is a concept that is really confusing for people. So I want you to just break it down really simple because people get probability confused with odds. And odds is what you'll see like in Las Vegas when they want you to bet on stuff. They'll list them as odds. So odds for is the number of successes to the number of failures. This symbol, this colon here, that's kind of your cue that they're giving you odds instead of probability. Like they're not using the fraction bar. So it's number of successes to numbers of failures. That's the odds for. So the odds for something happening lists the successes and then the failures. The opposite of that would be the odds against. Odds against is the exact flip. So instead of saying successes to failures, we're going to say failures to successes. So now, if you look at this first problem, it says a horse is favored to win the Kentucky Derby. The horse favored to win the Kentucky Derby is favored with 8-to-1 odds. 8-to-1 is how they'd say that. So that means we have 8 chances for winning and 1 chance for losing. So that'd be like odds against. So if there is 8 chances of winning and 1 chance of losing, how many total chances are there? 9. That's what's unique about odds is it doesn't have the total anywhere in them. So that means we have 9 possible outcomes. So if we're going to move to probability, guess what our denominator is? 9. If we're going to stay in odds, 9 is not involved at all. Okay, that's the difference. So it says find the probability that the horse is winning. Well, how many chances does he have for winning? 8 out of 9. So it's 8/9. So 9 is going to be your denominator if you're doing probability. So then, knowing that, what's the probability the horse would lose? 1/9. And the key word here is probability. That means you're going to put your total number of outcomes in the denominator. So then the next question they say are the odds that the horse is losing. So odds of losing, when it says odds, so that'd be odds against, right? So we're going to have losing, colon, winning. How many chances do they have to lose? 1. How many chances do they have to win? 8. Is the number 9 anywhere in there? No. 9 only shows up with probability. So it's 1 to 8 that the horse loses. Is that looking okay to everyone? So now the second one, we're going to start with probability. So this one, some of you will really appreciate. The probability of the Vikings making it to the Super Bowl in the next 10 years is 1/27th. That's probably higher than it is, right? Yeah. You could argue those stats. And we made these up. We're just practicing. I have no idea what the probability really is. So find the probability that the Vikings don't make it. So if the chance of them making it to the Super Bowl, this 1 represents the chance of them making it to the Super Bowl. So I'm going to the Super Bowl. Does this 27 represent them not making it? It's the total, exactly. It's the total. It's not odds against. So what's the chance of them not making it out of 27? 26. So 26 would be not making it. And 27 is our total outcomes. And this is listed as probability, so that's our bottom number is how many total we have. So if we're going to do odds right now, what 2 numbers would we be using? 1 and 26. If we're doing probability, the bottom number is always 27. Do you see the difference? That's the part that gets really confusing for kids. So hopefully if you can realize that, you'll be fine. So it says, what's the probability the Vikings don't make it? Well, if the probability of them making it is 1/27th, what's the probability of not making it? 26 out of 27. So not any work to show on these. These will go quick. The odds the Vikings don't make it. So odds against. We're going to say not making it to making it. So not making it is 26, and making it is 1. What are the odds the Vikings do make it? So odds of success would be 1 to 26. So we'd flip that. So these four that you see here, this answer, this one, and this one, are the four ways you would be able to answer these questions. There's not any other combination you'll use if you're doing probability and odds. Does that look okay? Any questions on the first two? So those are kind of basic setup ones for odds. You'll have those on your worksheet too. So the last one is a word problem. Not a hard word problem. They just put words in a problem. So it says, as a promotion for its anniversary, a store gives the customers scratch-off cards for a certain dollar amount off a minimum purchase. Have you seen that before? They do it sometimes at, where did I just get one? I don't know. But I have one at my house that I could go use there. I think Aldi. No idea. Anyways, they'll do like you can scratch off, and then you can say, oh, I'm getting 5% off today. I'm getting 10% off today. And you kind of scratch it when you're there. I think JCPenney's done it in the past, too. So it says 95% of the cards give the customers $5 off. 4% of the cards give the customer $10 off. And then the remaining 1% give the customer $25 off. So every card must be a winner, right? Every card's a winner here. There's no loser cards. They want people to get a discount. They just don't know how much. And obviously, doing 95% at the cheapest is smart for the company, isn't it? But the idea of getting 25% off or $25 off makes people happy, and they're going to scratch and buy something. And they normally, when they do this, you don't get to scratch ahead of time. You have to be at the register buying your stuff. They ring it up, and then you scratch. So you have to make the decision to buy before you scratch off. Smart for them to do, right? Because if you got something else, you might buy more. So it says, what are the odds of getting a card with $25 off? So the only thing we're talking about here is the $25 off, and that's 1%. So if it's a 1% chance of happening, what's the probability of getting a $25 off card? 1 out of 100, right? Does everyone understand that? So the probability would be 1 out of 100. We tend to think in probability, so I think you should think in probability and then move it to odds if that's what they're asking for. So did they ask for the probability? Is that the answer, 1 out of 100? No, they asked for the odds. So if the probability is 1 out of 100, the odds would be 1 to 99. They need to add up to 100. The next one says the odds against getting a card with $10 off. So what's the chance of getting a card with $10 off? It's 4%, so the chance of getting a card with $10 off would be 4 1/100ths. Does that make sense? 4 out of 100, that's the chance of getting that card. They're asking for the chance of not getting the card. So if getting the card probability, right, is 4 out of 100, not getting it would be 96 out of 100. So what would be the odds against? 96 to 4. Why 4? They need to add to 100, right? We have 4 chances to get the card and 96 to not. And since they asked for odds against, we put the not first. Does that seem okay? You guys try the last one. Now it's probability, not odds. So you can do that pretty quick. What's the probability of getting a card with $5 off? Can you just do it right now? What is it? 95%. 95% of the cards. So the probability is 95 out of 100. Let's just go one step further. What would be the odds for getting a card with $5 off? 95 to 5, right? Have to add up to 100. What would be the odds against? 5 to 95. And the only other thing they could ask us would be, what's the probability of not getting a card that's $5 off? And we would say 5 out of 100. So that's the 4 ways they could phrase those questions. Questions on that?